we're looking for references, I want references, not bibliography, you would select, whichever ones you have, and then just select it, and boom, it puts all your references in there, okay? You can type it in too, but it's a lot more work, a lot harder, but, you could do that. Okay, any questions with the second QEP outline quiz? Okay. All right, so we're good there. All right, and you can always go back. Like I said, here's the first QEP essay quiz to kind of get it there. And take a look at my comments on what I put when I graded the first quiz. And if you haven't done the first QEP quiz, you need to do it because that's a grade. Otherwise, without it, it's a 0. But it'll be a makeup. It'll be graded as makeup. But it's better than nothing. All right. And so that's for the second QEP essay quiz outline. Okay. Now we're going to go to lesson 10.1. So is there any other questions? We're just doing the outline, not the essay. Quiz 3, we take the outline and so quiz 3 will be an extension of what we're doing this week. All right. Well, 9.1 and 9.2 were due last week, so if they weren't done, you need to make those. You need to go ahead and do them. And I don't penalize. I mean, the only penalty for making up the homework is that you only get one try instead of unlimited tries. But it says 9.1, so 9.1 and 9.2 should already be done. If they're not done, you need to go ahead and do those. 9.3, 9.4, 9.5 are due this Sunday. Okay, so all the homework, the test 2 is due Sunday also in the outline. Okay, all right. Okay, so now we are on to chapter 10, counting methods. Well, chapter 10 is like a preview of what we get into chapter 11, which is probability and statistics. So 10 is kind of an introduction to that, counting methods. 10.1, we're going to get into the counting of systematic listing. So the objective here is to use a systematic approach to one-part counting task. In other words, one dice or one coin and so on. Use a product table for 2-part, like 2 dice or maybe 2 sets of names or whatever, and a tree diagram. We'll get into that, and we don't use the last one anymore. So, all right. Okay, so you get a dice out. Okay, the 1-part task results of simple 1-part tasks can often be listed easily, such as tossing a fair coin, or heads or tails. Okay, such as a coin or a dice has 6 sides to it. This particular dice has 12 sides to it, and so on. So for a regular dice like this, one, okay, it's known as, we call it a sample space. It'd be 1, 2, 3, 4, 5, 6 are all the possible outcomes that you could roll, right, and get one of these numbers. A coin, such as this nickel, is just what? Heads and tails, right? Whereas this 12-sided coin, or a 12-sided dice, right, that sample space would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So those are all the possibilities that you could roll from that. Now this dice here, this is kind of an unusual from a game. Okay, it's got queen, king, jack, and then it's got, this would be 12, or this is 1, 2, 3, that's 10. It's got a 10 in it, a 9, a club, this would be like an ace, and that would be this one here, that's the ace. So this would be, that would be the sample space for this game piece, okay, and so on. So you have to look at all the possibilities to see what kind of outcome you're going to get from each one of these, and they're all different. Okay. All right, so here we have a club. We'll call this club N. And in club N are 4 members. And they're Mike, Ted, Adam, and Helen. Okay? And we want to show how many ways can we select the president. Well, president, so you've got, we'll use M for Mike, T for Ted, A for Adam, and H for Helen. And so we've got 4 members, right? So there's 4 different ways to select the president, given that each one of these is equally a good shot at being president, okay? Questions there. So there's 4 possible ways to select the president. Okay, so, and so that would also be known as our sample space, right? Mike, Adam, Ted, and Helen is our sample space. There's 4 different ways. Okay, now if you've got these digits 2, 4, and 6. Here's our set 2, and we're looking at this set with numbers just 2, 4, and 6, and we want to select. So we want to determine the number of 2-digit numbers. Okay. That can be written using the digits 2, 4, and 6. So this would be a 2-part. So you've got here part 1, or digit 1, and digit 2. So let's go to the board. Digit 1 and digit 2, and let me give myself some more room here. So you've got 2, 4, 6, and the other way is also 2, 4, 6. So you're going to look at this as, all right, and let's see, did they want repeat? Oops, the other way. Determine the number of 2-digit numbers that can be written using digits from 2, 4, 6. The task consists of 2 parts. Choose the first digit, choose the second digit. Result of the 2-part task can be pictured. Okay, so now there's no restrictions on this. So you take the first digit 2. This is drying out. The first digit 2 and the second digit 2, so that's 22. And the first here, so here the first digit is 2 and the second digit is 4, that's 24. And 26. So the next one would be what? 42. How about the next one? 44 and 46. And the next one would be 62, 64, 66. So this is all the different ways to arrange the numbers for the digits to get for digits 2, 4, and 6. So you're looking at your answers here would be 22, 24, 26, 42, 44, 46, 62, 64, and 66. Okay, so the table is a way to quickly organize and determine what 2-digit numbers you can come up with from the numbers 2, 4, and 6. Okay, so it's it works for only 2, in this case, 2 digits. Okay, and so that's what we get there. All right, any questions with that? Okay, now here we have 2 dice, right? So we've got dice 1, we'll call it red dice, dice 2 is green dice. You can, in other words, you can roll the dice, right, and get 2 1s or snake eyes, right? Or 1 and a 2, or 1 and a 3, right? So, in other words, this would be 1 and a 1, or 1 and a 2, or 1 and a 3, or 1 and a 4, and so on. And so that's what this is showing. All this is known as the sample space, right? For every possibility of rolling 2 dice. So then next is 2 1, 2 2, 2 3, and so on, and 3 1, and 3 2, 3 3, and 4 1, 5 and 6. So altogether, you got 6 and 6. How many possibilities of rolling 2 dice do we really have? 36, right? So this is just a larger illustration of what we just showed here. This is just numbers 2, 4, 6. This is 1 through 6 for each one. Okay. All right. So we're going to get more into rolling dice later. So we'll get into that some more. Okay. Back to our club N. We want to find the number of ways of selecting a president and a secretary. So we can use the same concept for this example as well. So here's our board again. And so we've got, let's call this president and secretary. Okay, and we've got Mike, give myself some room here, Mike, Ted, Adam, Helen. And then the other way, Mike, Ted, Adam, and Helen. But with this one, it's different because we have a restriction. We want to know what are the different ways of selecting a president and a secretary. Well, if Mike is president, can he be a secretary? Can he have 2 positions? No, we can't have the same. So that's blank. So now it could be Mike could be president and Ted could be secretary, or Mike could be president, Adam could be secretary, or Mike could be president, Helen could be secretary. Okay? And then the next one is Ted could be president and Mike could be secretary, but Ted can't be both, so that's blank. And then the next would be Ted and Adam, and Ted and Helen, and so on. Next would be Adam and Mike, Adam and Ted, but Adam can't have both, so that's blank. So notice diagonally they're blank. Adam and Helen, and then Helen and Mike. Helen's president, Mike's secretary, and so on. Helen, president, Ted, secretary, Helen, Adam, and then of course Helen can't be both, so that's blank. So then you would just write out all the different ways of president and secretary. All right? So this is good when you've got two types of sample that you're working with. Okay? All right. So that's what that would look like. So there's 12 possibilities, right? Okay, questions there. Okay, next, find the number of ways Club N can appoint a committee of 2 members. Well, if in your committee, hold on, I wouldn't link this yet. In your committee, okay, it doesn't matter if it's Mike and Ted or Ted and Mike, so we can just eliminate that. And it doesn't matter if it's Mike and Adam or Adam and Mike, so we can essentially eliminate the bottom half. So how many ways can we select a two-member committee? 6, right? Because it doesn't matter which one's first or second, so order doesn't matter. Okay, so there's 6 questions there. All right, and then finally, I need to get attendance real quick. I'll do that at the end. A task that has more than 2 parts is not easily analyzed. So we want to use a tree diagram. So this would be an example of a tree diagram. So if we wanted to use a tree diagram to find the set of numbers 2, 4, and 6, only this time find the number of 3-digit numbers. Last time in the table we found the 2-digit numbers. Well, what if we wanted to find 3-digit numbers for set 2, 4, and 6? So what we do here is we write, okay, this is going to be our first digit, second digit, third digit. And the first digit is 2, 4, and 6. Okay? And they like to go ahead and connect all these up so it looks like a tree, which is fine. You don't have to, but okay, so since the first digit is a 2, then the second digit's not going to be a 2 because we don't want to repeat it. So if this is a 2, it can be a 4 or a 6, right? It's the second digit. So the third digit, so if this is a 2 and a 4, the third digit would be a what? Well, the only one that's left is 6, right? So here, if you have 2 and 6, the third digit would be a 4. Okay, so now we start with 4, so now you're going to use what? 2 and 6, right? So if you have a 4 and a 2, then the last digit would be a what? 6. 4 and 6, the last digit here would be a 2, right? And so if this first digit is a 6, then the second digit will either be a 2 or a 4. So if you have first digit 6, second digit is a 2, the third digit would have to be a 4 and 2, right? So therefore, our numbers here would be 246, 264, or what? 426, or 462, and how about the last one? 624 and 642. 426, right? It's 462, 624, or 642. Okay, and that's using the tree diagram. Okay, all right. Any other questions with that? All right, so no, we're not doing that. Okay, and that's it. That's 10.1. Next week, but we want to get a head start. So, oh yeah, don't worry about that. We're not doing those. That's not on the homework. All right, you're